I want to introduce Peter Hoeppe, who is at Munich Re, which is one of the largest, maybe the largest.
It depends on how you measure. Okay. In terms of premium income, we are.
Okay. There you go, insurance industry, where he is the head of the division on geo-risk research at the Corporate Climate Center. I've been at this game a long time, and then maybe 30 years ago, the only industry that was paying attention to climate change R&D was the reinsurance industry, which was haunting, among other places, the Geophysical Fluid Dynamics Lab. The university's neighborhood is one of the leading climate centers of the world, looking for advantage and understanding the risks. And they're still, and will be, in a lead position within industry. Dr. Hoeppe is a physicist. He's bridged academia and the private sector. He received his PhD from the distinguished Munich University, Ludwig Maximilian University. And his study was on meteorology and the health effects of air pollution. And he stayed on, he went for a postdoc at Yale, and then he went back to that institute. And he was for many years on the faculty in the Institute of Occupational and Environmental Medicine. We locate him as a specialist in environmental risk. He moved to Munich Re in 2004, and one of the things that I found on his CV is that he was one of the initiators of Desert Tech, the Desert Tech Industrial Initiative, which is the suggestion that Europe get a substantial amount of renewable energy from the Sahara, the wires or crossing under the Mediterranean. He's the chair for the national government of the Finance Forum on Climate Change, many other things, but picked out those two. Munich Re, I did not know, has its headquarters, its U.S. headquarters in Princeton on College Road. And there was a 2-day meeting just now for the UN, which has a unit called PSI, the Principles for Sustainable Insurance Initiative. So right in our own backyard that was going on. This talk is sponsored by Princeton Environment Institute, the Bentheim Center for Finance, and Sea Change Conservation, a fledgling, rapidly growing volunteer organization in town. Kathleen Biggins would like to say a couple of words about Sea Change Conversations before we have the talk.
Thank you. Hi guys, I know there are a couple of you who have seen me before, and we're kind of a mixed group, but Sea Change Conversations is an all-volunteer group that is dedicated to raising awareness of climate change and presenting it not as a green issue, not as a political issue, but something that affects the things that all Americans hold dear, like our jobs, our economy, our personal security, our safety, and our geopolitical stability. We've held 16 of these conversations throughout our community at this time, and we're so thrilled with that 16. And this is the second one that we've done in partnership with the university, and it's always wonderful to connect with everyone and CEI. And I'd like to give a special shout out to Morgan. Is Morgan here? No? Morgan from PEI, who's just done a wonderful job in facilitating this whole discussion. And also to the team members in Sea Change Conversation, Dr. C and Guyot. And there are about 10 of us all told. So thank you all for coming and joining us, and thank you so much, Dr. Hoeppe, for being here.
You're great.
Wait, where's Wolfgang? And Wolfgang Angstuber, who is the one who introduced to us. And who's going to be in the country for this very short window and has facilitated this entire event. So thank you, Wolfgang.
So as often happens, a guest brings many groups, local groups together. That's what's going on. Enough. It's time to hear from you. And you're catching a plane right after this talk.
Right. Thank you very much for your kind introduction, and thank you for your interest in what we do at Munich Re in analyzing the risks of climate change, but also in general risks caused by natural disasters. As already said by Professor Sokolov, Munich Re is a leading global reinsurance company. So our business model is to provide cover to the primary insurance companies. So we take some of the largest risks on this globe, and natural disaster risks are part of that. If we do that and want to write profitable business, we have to know as best as we can what's going on, whether there are trends, changes, if so, what are the processes behind it, and how can we quantify risk adequate premium, which is an important thing for an insurance company. By the way, on the right lower corner you see Munich Re America headquarters here in Princeton with these photovoltaic panels at the parking lot, producing a lot of the electricity they need themselves. And as already also said, the insurance industry has been the first industry to address climate change at all, because it affects our core business. So this is in our own interest. And in the case of Munich Re, we have been the first company to address this, which is proven by a printed publication dating back to 1973, in which you can read about a warming atmosphere, the rising CO2 level, and the question, what does it mean for the long-range risk trend, which has hardly been examined. 1 year later, a first meteorologist has been recruited by Munich Re. Now it's about 35 natural scientists working and analyzing natural disaster risks at Munich Re, some of them especially also the risks by climate change. And we have also contributed to IPCC reports, Intergovernmental Panel on Climate Change. My predecessor, Professor Bertz, has even been awarded part of the Nobel Peace Prize 2007, which has been given to IPCC. My current colleague, Eberhard Faust, has been a lead author for the fifth assessment report, which has been published in 2013-2014 for Working Group 2 on the impacts of climate change. Yeah. Is this better now? Yes. Okay. Sorry for that. Good that you remind me of that. Coming here to Princeton University, I don't think I have to tell you that climate change is real and what's behind it. Just one figure showing how dramatic global temperatures have developed in the last years. We had 3 years in a row with record temperatures, 2014, 2015 and 16. 16 of the 17 warmest years since we have records, and this is going back till 1880, have been in the period 2011 to 2016. So there is no doubt climate change is real. Who or where are the causes? Who are the countries responsible for climate change? There are two different ways to look at this question. The one is to look at the current emissions. You see that in the right pie chart, and there definitely China currently is contributing most. 30% of the annual emissions come from China, 14% from the United States, 7% from India, and then smaller fractions from other countries. But if you look at the accumulated CO2 molecules in the atmosphere, which decides how climate is changing, then you get to a different picture. Then it's still the United States with 27% of the accumulated emissions, followed by China, Russian Federation, also Germany is overrepresented. In the 1960s, 70s, a lot of CO2 has been emitted. So if you talk about responsibility of climate change, then certainly the accumulated concentrations are more important. This will shift more to China in the next years because China is continuing these high emissions, but it's if we discuss this and in the climate negotiations this is a question, definitely then both aspects have to be considered. Climate change doesn't only increase the air temperature, it also increases the sea level. Most of the historic sea level increase over the last 100 years of about 20 centimeters has been caused by thermal expansion of the ocean water. The ocean is warming up. If you warm up a liquid, it expands. In the case of the oceans, it can only go up. There's only one way to go. And this is the main contributor still to sea level rise. Only minor parts come from melting glaciers on the continents, on Greenland, contributing also to sea level rise. IPCC expects further sea level rise in this century by up to another 81 centimeters. Other studies see even increases of more than 1 meter. And there has been a calculation already by Lloyd's after Sandy, Hurricane Sandy, which has hit Manhattan badly, that the 20 centimeters we have caused by climate change already have increased the Sandy storm surge loss on the southern tip of Manhattan by 30%. So this means climate change, and this is also already part of the answer to the title of my talk, it has already started to cost us a lot of money. Sandy losses amount to about 30 billion US dollars, a large part of that in the Manhattan, New York City area, and if you have 30% of this, then this is billions, which can be attributed to climate change already. We have started in the 1970s to collect all available data on natural disaster losses, be it material losses, be it human losses, and have built up a database, which is the most comprehensive database, which is available with more than 40,000 individual events documented in this database. And if we do some analysis of this data, like here you see the number of the relevant events. The different colors represent the different peril families. Red are the natural disasters having their origin in the Earth's crust, which is earthquakes, tsunamis, volcano eruptions. There you don't see any trend. There is some fluctuation from year to year, but no trend. The whole trend, the tripling of the number of loss-relevant events since 1980, is caused by weather-related events. So there is quite some reason to assume that some changes in the atmosphere may have contributed to that. And let's have a look at the current or last hurricane season. And in this season, certainly Houston had a problem because Houston had a landfall of a devastating Hurricane Harvey, which got stuck there in the Houston area and poured down precipitation of up to 1.60 meters, which is about this height, and this has been an absolute record, and it has caused total losses, and you see an asterisk there because this is not the final assessment. We are still in the assessment process, so we think it's around 85 billion US dollars total loss, and 30 billion of that is going to be paid by the insurance industry, 60 people killed. The next one has been Irma, which has devastated parts of Cuba, but also Florida. Estimate of total loss 67 billion US dollars, insured loss 32 billion. There the insured fraction or ratio is higher because the windstorm, the mechanical loss has been higher, and for this so the insurance penetration is much higher than for flood losses. So this is the reason for this difference. And then we had Hurricane Maria, which has devastated Puerto Rico, 63 billion the estimate of total loss and 30 billion of the insured loss. Let's have a look at the trend of the loss-relevant hurricane events in the North Atlantic. The number, there you see it has been on a high level, but it hasn't been a record level in terms of the number. But if you look at the losses, and there you see the inflation-adjusted total economic losses, the green bars, and the insured losses, the blue bars. There you see it's a record loss. Never before hurricanes have cost as much money to repair the damages, infrastructure, houses, etc. So this has been a record year in terms of hurricane losses. There you see from the distance, perhaps you can't see it because it's too small, but actually I will make the presentation available and I can send it to you, then you can study the figures. These are the 10 most expensive hurricane events, still led by Hurricane Katrina back in 2005 with a total loss of 125 billion. And if we fit in now the 3 hurricanes of this year, then you see Harvey has been the second most expensive in the history of North Atlantic hurricanes, and the 2 others, Irma and Maria, go then on rank number 4 and 5. So 3 hurricanes in one season, making it into the top 5 events of hurricanes. And there certainly is an association with sea surface temperature. Sea surface temperature decides on evaporation of water vapor into the atmosphere and on the fuel for a hurricane. And there we have a complex situation because we have a natural fluctuation of sea surface temperatures. These are the so-called cold and warm phases. Here you... No, doesn't work anymore. On the upper line, you see the levels of sea surface temperatures. You see decades with warmer temperatures followed by cooler temperatures. We call them cold and warm phases of the Atlantic multi-decadal oscillations. But you also see that they went up stepwise from one warm phase to the next one, and this current warm phase is much higher compared to the warm phase before. And this also is reflected or can be seen in the number of major hurricanes. These are the numbers at the bottom: 1.3 in a cold phase, 2.5 in a warm phase, followed by 1.5 and 3.5. Also there we see a stepwise increase, and this only can be explained by global warming. So we have a modulated natural cycle by global warming, which drives temperatures higher and higher. So, no, nothing doesn't work anymore. And there is clear indication by climate modelers, and actually this is a paper which has been produced here in Princeton by the GFDL, which has modeled how the distribution of strong hurricanes will be in the future because of climate change. And they found that a doubling of the frequency of category 4 and 5 storms, the category we have seen with Harvey, with Irma and Maria, by the end of the 21st century. So a doubling of the number of these strong. The total number of tropical storms in the Atlantic Ocean will not change significantly. This is also a result of such studies. Yeah, if we put this all together, we get that the total insured losses of these 3 hurricanes will amount to about 100 billion. More than double as much the total economic losses. Then we had other weather-related events this year: floods in China, wildfires in USA, in October in California, Typhoon Hatu in the Northwest Pacific. Then we had floods in South Asia, floods in Peru in a hailstorm, and severe storms in May here in this country. If we put this together, then there is a high probability that this year will not be only the year with the highest hurricane losses, but the year with the highest weather-related catastrophe losses at all. There you see the history. By now, until recently, 2005 has been the year with 269 billion. But if we add the figures, the loss figures we have in our database already, then we come above this 269. So most probably this will become the most expensive weather-related NatCat year on history. Let's have a look at some different perils and what we see there. The first one is floods. There we see a significant increase in intense precipitation events, in loss-relevant flood events. You see that here on a global level. You see we had 60 or so in the early 1980s, and now this has gone up to about 300. So this is 5 times as many. If we look at the losses, however, and this is really an interesting thing. If we look at the losses, here we see the nominal losses, which is the losses at the time when a catastrophe occurs, not inflation adjusted, not adjusted for other changes. If we then adjust it for inflation, then it looks different. And there you see that starting in the 1990s till today, the trend is gone. And if we then normalize it, which means we consider development of wealth and population growth, so in other words, we calculate how high would a loss of a historic event be today with the exposure of today, then we even get to this red curve. And what do we see? We see a decrease in flood losses. Isn't that strange? We have more events, but we see a decrease in the losses. And I will explain you what's behind it. It's prevention measures. So for flood losses, river flood losses, you can invest into prevention and reduce the losses significantly. Especially in China, this has happened. A lot of money went into this project, but it pays back. it pays back in the way that even though we have a higher hazard, we see lower losses on a global level. This is not the case, unfortunately, with convective events. Convective events are thunderstorm-related events. It can be tornadoes, hailstorms, intense precipitation, which can develop out of these big thunderstorm cells. We had a real extreme event in Germany, a country where we have moderate climate and really normally don't have these large catastrophes compared to what you have here in your country. But we had a hailstorm which has resulted in losses of 3.6 billion euros, and by this it has been worldwide the most expensive hailstorm with hailstones with diameters up to 11 centimeters, which is much more than a tennis ball. And this has been a new experience for us in Germany. In the Netherlands last year, they had a similar event, also a €1 billion loss due to a hailstorm. Many of these greenhouses have been destroyed there. And there is a coincidence of an extreme meteorological situation, because right on this day of this hailstorm, the humidity of the air has been the highest ever recorded. They had a dew point temperature of 25 degrees Celsius. Never before such a high absolute humidity has been recorded. And the convective storm events increase worldwide, and the losses also go up. Here you see, just look at the red curve. This is the best curve if you want to compare historical losses with the current losses, and there you see a significant increase, especially since the 2008, 2009. We have this increase in the losses. If we have the normalized losses, this means we cannot explain this increase anymore by higher exposed values, because this is adjusted for already. We only can explain it by changes on the hazard side. So this is another piece of evidence that climate change may have contributed to that. And actually we have done a profound and into-depth study of the situation here in the United States. A PhD student and 3 of my colleagues have even put together a peer-reviewed scientific paper on the results published in Weather, Climate and Society, the Journal of the American Meteorological Society. What we did is we brought together our loss data with the meteorological data for a period of 40 years, and we had the result that there's a clear association. Our loss patterns have changed because the patterns in the atmosphere have changed in the way that there are more days of beneficial or good conditions for the origin or generation of big thunderstorm cells. And if we look into the future again, and we can do this with climate models, and this has been done by a study by Diffenbaugh and co-authors, they have found that with modeling with climate ensembles, that they have had seen robust increases in the occurrence of severe thunderstorm environments over the eastern United States in response to further global warming. So the signal we have detected is in line with what climate models suggest that due to climate change will change. Similar thing with heat waves and droughts. There has been this big or large heat wave and drought in July 2012. The whole summer has been real dry in the Midwest here in this country, and this has resulted in agricultural losses of about $20 billion. More than 3/4 of that had been insured, because the US farmers have the best insurance of all countries. They have a harvest insurance, so if they get a return on their harvest less than 80% of the expected return, they get some indemnification from the insurance policies. So, but this has been the hottest July on record in the US, and we see more and more of the record temperatures. This study has assessed the distribution of temperature records, and has found that already today, on a global level, there are 5 times more temperature records than you would expect in a statistical model without a change in the general climatic conditions. And worldwide, worldwide the number is 5 times as high. Actually, this is the same slide condensed to this one statement. And one concrete example now, not from the US, but from Munich, where Munich Re headquarters is, and there is a meteorological institute of the Ludwig-Maximilians University there, and they measure temperature on a routine basis, and here you see the development of the number of days per year with an air temperature of more than 30 degrees Celsius, which we call a hot day, and you see the dramatic change of the frequency of these hot days beginning in the 1980s with just a few days, and now in the last, this year, 33 days, 2 years ago, even 37 days as hot as 30 degrees. Climate change is not only real and accepted by most scientists, but also now by the economists, because they increasingly see climate change as an economic problem. What you see here, and I will enlarge some of the information, is a risk landscape. They produce every year at the World Economic Forum in Davos in January. So about 700 economists rank and assess 35 given risks in respect to the likelihood of the occurrence and the economic impact. And to the rightest most upper corner, you find the risk with the highest likelihood and highest impact. And there you find extreme weather events, natural disasters, failure of climate change, mitigation and adaptation, and you also find as high impact risks, water crisis, food crisis, also linked with climate change. So it's mainstream and accepted by economists that this is one of the largest economic risks on this globe these days. So there's good reason to think about how we can manage these risks, how we can mitigate global warming. One approach definitely is prevention of losses. Another example from Germany. Germany had Hamburg had a big storm surge in 1962 with a loss of 1.5 billion euros around, and since then 2.2 billion have been invested into flood protection within the city of Hamburg. Since then, nine storm surges occurred with higher levels of the river in the city than in 1962, and hardly any damage occurred anymore. So by the investment of 2.2 billion, losses of more than 20 billion, this is what we have assessed roughly, have been avoided. So this is a smart way to manage risk, to invest at the right point. The next example here from the United States, from the Mississippi, there's been a real large flood, a century or 100-year event in 2011 with record flood levels. And there had been prevention measures before. The Army Corps of Engineers has organized the building of 3,500 kilometers of levees, reservoirs, emergency outlets, and by this they have succeeded in avoiding losses in the range of 100 billion US dollars. What you see here is the actual damage which actually occurred, property damage, agricultural damage, and the repair costs of the dikes. And then you see the potential damage. If these prevention measures wouldn't have been in place, then these damages would have occurred. And if you just build the difference between the two values, then you see how much money can be saved by these measures. And you can also do some smaller preventive measures at your own house. But in order to know what to do, it's good to have a research institute, and this is the Insurance Institute for Business and Home Safety based in South Carolina with this big lab. You see here the fans of the wind tunnel, and you see the wind tunnel in which you can put whole houses. You can apply wind velocities of 180 kilometers per hour. This is a category 3 hurricane, and test building materials. And actually they did that with 2 almost equal houses. Only in the right house, 5% more money had been invested to fit the roof in a better way and to do some other small things. And after the end of this experiment with the Category 3 hurricane, the right house was standing there almost undamaged, and the left house was totally gone. You can look at the video. There's the link which you will get with my presentation. It's really fascinating to watch that. And actually, the cooperation of Munich Re with IBHS has resulted in an app for everybody who wants to build a house or who wants to retrofit a house. There you can learn what you have to do or what you can do to make your house less vulnerable against windstorm, against hail, against flooding. So this is a free app you can download from the App Store, and this has been a cooperation of IBHS, this institute in South Carolina, and Munich Re America here in Princeton. Munich Re, for a long time, has dealt with the topic of climate change. In 2008, the Munich Re Group even has defined climate change as a strategic topic for the whole Munich Re Group, which means we think not only all business lines are affected, but also the central units. We need a central coordinating steering unit to coordinate the Munich Re activities. And the strategy for this strategic topic is based on 3 pillars. The first one is our core business. For our core business, it is very important to be in contact with the researchers here in Princeton, at Columbia University, in other places, and also to do own in-house research on the effects of climate change, on the analysis of trends, to then consider these findings in our risk models. This is essential to be able to do profitable business also in the future. The next pillar is a pillar where we think we can even develop business out of these changes, especially taking risks from producers or investors into new technologies. New technologies always come with new risks. Like, for example, photovoltaic comes with the risk of premature aging cells, that after 10, 15 years, the output is much less than expected, which is bad for an investor. So we have developed a performance guarantee policy for investors or producers of photovoltaic, which guarantee a certain efficiency. If the efficiency is not there, then there is a payout from this insurance policy. Or also delivery guarantees for wind and sun. They are volatile. There are seasons with less wind, with less sun, which is bad for an investor into these technologies. And if then there is a policy which covers the difference, then this can incentivize even investors into these clean and new technologies. The third pillar is asset management. As a large reinsurer, we have to have a lot of capital to be able to pay even for the largest losses, and these assets have to be managed. And so we have an in-house process that we exchange our views, the people who know the risks and the ones who are the asset managers, so that we try to do our best to invest into the winners of climate change, not into the losers of climate change, but also to invest into clean technologies. There is currently a program of 8 billion euro investment by Munich Re into renewable energies, grids, and storage facilities, because we think it's not only good for the environment, for the climate, but it's also a profitable investment and a good long-term investment. And here again, this is part of the story. We have become carbon neutral in our business operation in 2015 for the whole group, in 2009 already for the Munich headquarters. We do this by becoming more energy efficient. We do this by investing into things like this. We do this also as we have to use a plane once in a while. As a global company, I have to fly here to Princeton, but we compensate at least the emissions there by investing into small energy power plants in China, which are small river power plants, which are geothermal projects in Indonesia, and wind farms in India, which replace the emissions then by these renewable energies there. And we also think we have to care for the most vulnerable people on this globe, and this is not us in the industrialized countries. We can manage the risk, and we have the money, we have the capacity to adapt and to reconstruct things after a big extreme event. But people in developing countries, poor countries, they don't have that. They are already living in areas with extreme climates, and if there is just a small shift, this may mean that they cannot grow corn anymore, and that they cannot live in these regions anymore. So I think we as the industrialized countries, we have a responsibility to help these people. They have come or are coming increasingly in a bad situation without having contributed to the causes. We, the industrialized countries, have caused the problem. So in order to find some ways to help these people with insurance-related mechanisms, we have founded a non-profit organization. It's an NGO based in Bonn, close to the head offices of UNFCCC, where insurers work together with NGOs, with scientists to find solutions for these most vulnerable people. And we think we have had an influence on the climate negotiations with our publications, with our discussions with the delegations at these climate summits. And there has been the agreement in Cancun 2010 at the COP on a loss and damage program. 1 year later in Warsaw, there has been an agreement on the Warsaw International Mechanism, which is really focusing on support for adaptation in developing countries. MCI, this organization, has received some funding from the German Environmental Ministry. Actually, it's 4 million euros to implement and test microinsurance products on 3 Caribbean islands, St. Lucia, Grenada and Jamaica, to help poor people to get back onto their feet again after a hurricane landfall or something else. And these are parametric insurance products, which means they are only based on a certain value of wind speed or precipitation, so that there is no loss adjuster necessary. They get their payout and get notification on their cell phone 1 day after the event whether there will be a payout, and latest after 14 days they have the money on their account, and so they can repair things easily and get back. We had at the COP in Bonn, MCI was awarded the Momentum of Change Award from UNFCCC, and we had the chance to fly in a beekeeper from St. Lucia who has been affected, and he said this insurance policy has helped him so much, because after that hurricane the bees didn't find any nutrition anymore. They would have starved, and so he could buy some nutrition for them, feed them for the time needed, and so he is still in business. He would have been out of business if he would not have had that. Another big step has been the decision of the G7 countries, including US certainly, on an climate insurance project, Insure Resilience, and in the climate insurance is also part of the Paris Agreement. Just a few words to Insure Resilience, because this is a real big thing. The objectives of this project is to provide basic insurance against weather extremes to 400 million additional people in poor countries who don't have any access yet to insurance. So the target group is really the poorest with an income of less than $2 per day. So this is a real hard task to make insurance available. They don't have the money to pay for a risk-adequate premium. So there is a talk about subsidies for the premiums, definitely, and the G7 governments already have made money available. Just in Bonn, Germany has put another 125 million US dollars into that budget. Now it's 680 million US dollars, and things are now taking up pace. Munich Re has been involved from the beginning to consult the German government for this project, and together with MCI, the Munich Climate Insurance Initiative, we are still on board and now consulting the Secretariat which is also in Bonn, how to implement now these projects. And actually, just 2 weeks ago at COP23 in Bonn, a global partnership has been launched on insurer resilience, which is a great step forward, because this brings in all stakeholders at one table, representatives of the vulnerable countries, the V20 countries, representatives of the donor countries, representatives of insurance industry, of scientists, and so we have them all pulling the same rope in the same direction. You all know what the Paris Agreement has brought. I think it has been a real great breakthrough. Never before 195 countries have agreed to do a thing together to keep global warming below 2 degrees, aiming even at 1.5 degrees, to make funding money available for the developing countries starting in 2020 in the range of $100 billion US, and the whole climate insurance thing, which is also which can be found in the Paris Agreement. Finally, at the end, I would like to introduce one thing which is available freely to everybody, and it's online. You don't even have to register. This is the new NatCat service analysis tool, by which you can access our loss data. Loss data, I have shown you some of the statistics. You can design your own statistics. You can have trends of frequencies of events, of the losses. You can have bar charts, pie charts of distributions. You can produce maps where you see the distribution of all of the events. You can choose the time for which you want to do the analysis. Longest time is 1980 to 2016, but you can do it for a single year, a 5-year period, a 10-year period. You can choose the specific peril, or whether it be convective storms, tropical cyclones like hurricanes, or floods, droughts, and you can use that freely in your presentations and in publications. So this is an easy access, and try it out. It's easy to handle, and very quick. Within 10 minutes, you have very interesting statistics, graphs, and other things. So I get to my conclusion. Climate change is real. We have been convinced about this for decades now. It can only be slowed down. This is the bad news. We cannot stop it anymore. There's no means to stop it. Even if from tomorrow onwards no greenhouse gases would be emitted anymore, the climate would warm for another 1 or 2 centuries. But we can slow it down, and there is still a possibility that we could reach the 2 degree, or stay below the 2 degree threshold. There is more and more scientific evidence for causal links between global warming and increasing frequencies and intensities of natural catastrophes. Most of the real high-level research comes from this country. Here, Princeton, other famous institutes here, NASA, NOAA, are providing the valuable data, which is really a valuable contribution to the assessment of climate change and its effects. In order to avoid unmanageable conditions, we definitely have to mitigate global warming. This is a thing we have to do in our responsibility for the next generations, but we also have to adapt. This is also already important for us, as you have seen with the flood losses and the benefits of adaptation, in this case prevention measures. More insurance against natural catastrophes will become part of the adaptation. Only after prevention measures have been made in an economical, sensible way, then the next step could be that if you decide, oh, it doesn't make sense, seen from economics standpoint, to invest into prevention. It makes more sense to invest into insurance, because it's rare events, or they are local events. Like tornadoes, for example, a good example of good insurability, because nobody knows where they hit, and only a small area in general is affected. So insurance plays a role. G7 The Insure Resilience project, this is the name that G7 have given to that project, is just one example. We as the insurance industry, and it's not only Munich Re, it's also other large reinsurers especially, can support climate change mitigation and adaptation by providing insurance solutions for people who want to go into the clean energies, into energy efficiency projects, and want to find somebody who takes the new risks, but also by investing ourselves into clean energy and energy efficiency projects, and by provision of know-how and disaster prevention. So we are a partner of many governments, and they ask us for our advice how to organize prevention, and or in the first place they ask us whether we see any changes, and then they ask us what they can do about that, and we are happy to consult that. The event which has taken place yesterday and today here of the signatories of the Sustainable Principles for Insurance, they are really committed to contribute to a more sustainable and more resilient world. Yeah. So the answer, and this is the final sentence to the questions in my title. I believe yes, we are already paying for climate change, for increasing losses and damages, and also for prevention measures. These are all costs which we would not have if climate change would not be there. So, yes, we pay for climate change already, and we will pay even more in the future. Thank you very much for your interest, and hopefully we have some... Thank you. And I think we have 10 minutes time for questions, statements, whatever you want.
For the numbers that you indicated earlier when you talked about insured losses, does that include federal insurance as well? So
The National Flood Insurance Program.
those numbers included?
Yes, the NFIP figures are included, but the losses are only the direct losses, which means these are the costs to repair the damages. It's not secondary losses which we had, for example, with Katrina in New Orleans, that large amounts of the population left the city and never came back. Loss of labor, which is bad for the economy, so this is a secondary loss. This is not considered in these loss figures. So the losses are higher, the real losses are higher. Yeah?
Yes, I'm curious about the insurance to poor people that have like less than $2 per day, I think you mentioned.
Yeah.
So what type of insurance is that?
That's parametric insurance, which means you pay a small premium and get a payout once, and there are many institutes doing these calculations. Once a level of a meteorological parameter reaches a destructive level, so damages can be expected. So on these 3 Caribbean islands, there are payouts. There are different payout layers. The first one is for a 15-year event, 15. So this is a relatively small event, but people need to see some payouts to believe in insurance. If you only would insure 100-year events and some generations would never see a payout, they would never buy insurance again. So you have to start at a low level. So we have the 15, we have the 30 and 50-year event, and then you have to calculate how high is the wind velocity, which only occurs every 15, every 30, every 50 years. And once this is reached, then they get a notification, and then they get a predetermined amount of payout, which could be 10 times the premium or even 100 times the premium. It depends on the return period. Yeah?
In New Jersey, we have something called the Blue Acres program. It's not a big program, but the government funds can buy property that has frequent repeat events and convert it into floodplain natural land. So does the private insurance industry have any sort of product or reaction to repeat occurrences? And does it trigger anything like that where you will pay someone to kind of convert their improved or constructed property into something natural.
Yeah. This is a question of the premium. The premium should reflect the expected loss. If you invest into your house and make it stronger or less vulnerable, then the premium should go down accordingly. And this is something you can negotiate with your insurer. And this is the case but the investment doesn't come from the insurance industry. It must come from the insureds. And then if they prove the risk has decreased, then they should pay a lower premium in respect for, or in as a reaction for that. So this is definitely something on the long term, or if it's still possible, it would, or the insurance industry always communicates that we would like to see more awareness by the political authorities who design new areas for settlements, for industrial plants, not to build them into already known floodplains, what is still happening. And not only to consider the current condition, but also to model the future condition, because the floodplains of today are not the same as the floodplains of in 50 years, when these buildings perhaps still should be there. Yeah.
Still seeing a lot of building in some areas that are highly susceptible to current and future flooding, as we've been discussing. I've been wondering how it is that people in South Florida, for example, are they going there? Are they uninsured? How does that work?
I don't know whether they're uninsured, but they pay a lot for their insurance. In some places in Florida, if you are very close to the coastline, an insurance for your residential building can cost $10,000 or even more per year. And for an individual home, yeah. But this hardly reflects the real risk, because in Florida we have a situation that after some hurricanes, the insurance premiums went up, and then the state thought we don't want to scare people to move into Florida by these high insurance premiums. Then they founded a national state-run insurance company which subsidized, or which brought the premiums down, and which causes a lot of problem for the primary insurance market, and does not send the right signal anymore, because normally insurance premium is a price tag on risk. But this is not the case anymore if these are not the risk-adequate premiums.
So Florida taxpayers are now subsidizing
Yeah.
insurance for people with coastal property.
Yeah.
More questions?
Yeah. Yeah, it's really hard it's hard already to quantify the costs already occurring today being attributed to climate change, because you have so much volatility, especially in the rare events, and also some other changes in vulnerability of houses if they are built differently, and it's even more difficult to do this in the future, because then you have the uncertainty of the climate models also in the system. What we do is we like here we communicate our findings, and we try to raise awareness by this. We are scared of what we see, that things are still manageable, and I also think that in the US, in Europe, still in 50 years things will stay insurable. But the premiums will go up accordingly where you live, and against what peril you want to get insurance. This is the message we have. And actually, I have the impression I had been at Munich University, a professor there before I joined Munich Re. And I had the experience, even which was really, really surprising, that politicians seem to believe me now more than they believed me as a researcher at the university. That's a funny thing. And this is because we have these figures we communicate in our books, which are transparent. Everybody can have a look into that and verify whether this is a real natural catastrophe that has happened and the loss level is real or not. And so perhaps this increases credibility. Yeah?
You're talking about the new insurance solutions for climate-friendly technologies. I think including if there's less sun or wind than had in the
Yeah.
Who buys those policies and how wide are they?
The large investors, for example, investors into offshore wind parks, they buy this. And there's an increasing demand, by the way, in these insurance policies, because we have these large offshore wind plants in the North Sea off the German coastline. And we had 3 years in a row with lower wind speeds than on average, and they had a problem. The investors had a problem because they didn't get the money back they expected. So they can transfer this risk with this insurance policy.
Let's thank our speaker and wish him a return.
Yeah, thank you. Thank you.